Alright, let's continue what we started in the last video, where I'm going to give you some points on a parabola, and we're going to have to find the equation of the parabola using those points. So this is going to be a parabola with two roots. One of them is going to be 3. The other one, we don't know what it is. And I'm also going to tell you that the parabola passes through the point 5, -4, and the point -3, -12. So what can we do with this? Well, we know that we can't use root form when we only have one of the roots. We tried that in the last video, and it didn't work. But what we do have here is we have 2 points here, and we have a third point here. Because a root, the y value is 0, so we can change the root of 3 to the point 3, 0. So now we're just left with 3 points that are on the graph. So what can we do with that? Well, we can actually find the equation of the graph using just these 3 points, even though we don't know if any of them are the vertex. We know this is a root, but we're basically ignoring that by turning this into a point here. So here's what we can do. If you notice in the standard form, the vertex form, the root form, all the forms, there's always 3 variables besides x and y, and I've used a, b, and c. So what that means is that we have 3 variables to solve for, and we can make 3 separate equations, one for each of these points, because each of these points is an x and y value. So the easiest way to do this would be the most basic form, which is standard form. Y equals ax squared plus bx plus c. Since there's no parentheses or anything here, this is going to be the easiest form to do simultaneous equations with. So let's start with this point here. Y value of 0 equals a times x of 3 squared. So that's going to be a times 3 squared plus b times x of 3 plus c. Now let's make another equation using this point, 5, -4. So y of -4 equals a times x of 5 squared plus b times x of 5 plus c. And finally this point, y of -12 equals a times x of -3 squared plus b of -3 plus c. So now let's take these 3 equations and just simplify them out with the squares here. So we're going to get 9a plus 3b plus c. And now here we're going to get 25a plus 5b plus c. And for the last one, we'll get 9a minus 3b plus c. So now we have a system of equations, 3 simultaneous equations, 3 variables. So we can solve for each variable one at a time. The way we do this, in case you don't remember, is we have to eliminate one variable at a time. So is there a variable where we have the same number of that variable in 2 of these equations? Well, look at the first 2. We have 1c in both. So we can subtract the second equation from the first one to get rid of the c's. So we will have 0 minus -4 equals 4. 9a minus 25a is -16a. And 3b minus 5b equals -2b. Now we have 1c in the last 2 equations as well. So let's subtract this bottom equation from the middle one. -4 minus -12 is 8. 25 minus 9 is 16a. And 5 minus -3 will be 8b. So now, if we look here, we see we have a -16a and a 16a. So we can just add these 2 equations together to get rid of the a's. So now, if we add them, we'll get 12 equals, the a's are gone, negative 2b plus 8b is 6b. So b equals 2. There we go. There's the first variable. Now we can get a very easily by substituting back into either one of these. So if we take the first one here, we get 4 equals negative 16a minus 2 times 2, so minus 4. Negative 16a will equal 8, and a will be negative 1/2. And now finding c will be very easy. We can take any of these three equations to substitute a and b back in. If we use the first one, we'll get 0 equals 9 times negative 1/2. That will be negative 9 over 2 plus 3 times 2 plus 6 plus c equals 0. So this is over here, this is 3 over 2. So c is, if we move it to the other side, negative 3 over 2. There we go. We have a, b, and c. So substitute that back into the standard form equation, and we will get y equals negative 1/2 x squared plus 2x minus 3 over 2. So just using a root and 2 other points, we got the equation. Now we're going to do the same thing one more time, except this time we're going to graph it to prove that we really can, just given 3 points, this point, and this point. We're going to prove that just given these 3 points on the graph, we can draw the entire graph. So the first thing you might think to do is, well, let's just plot these points so we get a general idea of where the graph's going to go through. So we can plot negative 1, 3. We could plot 7, 5. And we cannot plot 10, 14, since that is way up here somewhere. So this doesn't really tell us much. We know the graph's going through there and going through there. It's probably going to be somewhere in here. But really don't know for sure until we start solving this. So again, using the standard form equation, that's going to be the easiest one to substitute into. We just have to make 3 equations. The first one with y as 3 and x as negative 1. Now with y as 5 and x as 7. And finally with y as 14 and x as 10. Okay, now let's simplify all of these out. So we'll get 3 equals a minus b plus c. Let me keep these aligned here. We get 5 equals 49a plus 7b plus c. And 14 equals 100a plus 10b plus c. Okay, so again, you can see that we have one c in each of these, so this is not that hard to do. We can start by subtracting the second equation from the first one. We'll get negative 2 equals negative 48a minus 8b. And now do that again for the second and third ones. Subtract. We'll get negative 9 equals negative 51a minus 3b. So now this is a little bit harder because these numbers here don't exactly go with each other very well. But let's see. We want to find a lowest common multiple for 48 and 51 to get the same number of a's, or the same number of b's by finding the LCM for 8 and 3. Well, 8 and 3 is obviously going to be a lot easier. What we're going to have to do is, what is the lowest common multiple of 8 and 3? It's 24. So to get to 24b, we're going to multiply this equation times 3 and multiply this equation times 8. And we will get that for the first equation, and multiplying that times 8. Negative 51 times 8, that's going to be negative 408. Okay, so now we have negative 24b in both. So if we add them, we'll end up with negative 48. So what we want to do is subtract one from the other. So if we subtract the bottom from the top, we'll have negative 24 minus negative 24, which will be 0b. So the b's will disappear. So we are subtracting the bottom equation from the top equation. Negative 6 minus negative 72 is negative 6 plus 72. That's positive 66. And negative 144 plus 408. It's a little tricky to do in your head. Let's see. Negative 144 plus 408 is the same as 408 minus 144. We just flipped it around. Do a little quick subtraction there. Okay, so we're going to get 264a. Now, to solve for a, we need to do 264 divided by, 266 divided by 264. And if you don't see that right away, that is 1/4, because 66 times 2 is 132, times 2 again is 264. So to get from 264 to 66, we divide by 4, which means a is 1/4. Okay, that was a little more work to get the first one, the first variable, but now the others won't be as hard. So let's substitute back into either of these two equations. We're substituting a in. So what number is going to multiply by a easier, 48 or 51? Well, that's going to be 48. We're going to get an integer number doing that. So we'll get negative 2 equals negative 48 times 1/4 is negative 12 minus 8b. So now we'll get negative 8b equals 10. So b will be negative 5/4. And now to find c, we just got to find an equation with all three variables. Well, look at this one here. That's nice and easy. Very simple. 3 equals a of 1/4 minus b of negative 5/4. So plus 5/4 plus c. So c, this is 6/4. 3 minus 6/4 is 3 minus 3/2. So that's 3/2. And there we go. We have all three of our variables. So the equation is y equals 1/4 x squared minus 5/4 x plus c of 3/2. All right, I'm just going to write that over here because we have more work that we need to do still in order to graph this. So I'm going to clear that. We have the equation here of the graph, but now we need to still graph it. And we can't graph right out of standard form. We need to use vertex or root form. So let's see if we can use root form. Root form would be if we factor this. So how can we factor this? We have fractions and everything. Well, what we want to do is get rid of the fractions. So we can factor out a fraction. so that they become whole numbers. Here we're dividing by 4, and here we're dividing by 2. So if we factor out a 1/4, then all the fractions are going to go away. We'll get x squared minus 5x. Now we factor out a 1/4, so since there was only a 2 here, the divide by 2 times 4 changes to multiplying by 2. Multiply the numerator by 2, and we get plus 6. Or you could look at this as 3 over 2 divided by the 1/4 we factored out. So 3 over 2 times 4 is 6. Okay. So now that we've factored that out, this is a very easy factoring problem. This is x minus 3 times x minus 2. So what do we need to make x equal to get y equal to 0? In this term, it's 3. In this term, it's 2. So those are our roots, 2 and 3. So you might be thinking, so we have these 2 roots here, and then we have points over here and here. It doesn't look like we can draw a smooth curve through these, or it looks like it would be way too wide. But remember, look at the leading coefficient here in either standard form or root form or any of the forms. It shows us how steep the graph is. So since we have a 1/4 here, we know the graph is not steep at all. It's very wide. So the parabola is actually going to look something like this. So we just have to connect the dots here. There is our graph. So we can see it passes through -1, 3, 7, 5, and 10, 14. That would just be up here somewhere. We don't have 14 up here. It'd be right about there. And we can see that the graph does approach that point. So we could go through the effort of finding the vertex. It would be at an x value of 2.5, and we would substitute that into this to find y. But we already know about what it's going to be. We can just look at the graph now and see that it's going to be just below 0, and that's because these 2 roots are so close together, and this graph is so wide that it just barely dips below the x-axis. You can barely even see it on this graph that it dips below the x-axis. But that is enough information. We have 4 points here. This is a good enough graph that we can say we did a good job there. So what we did was we started with 3 random points placed in very different, strange places along the graph, and doing a lot of solving and a lot of work to get here. We were able to draw a pretty nice graph. So that's pretty cool that we can start with such vague information and end up with a full graph. And on that note, I think we are done with graphing quadratic equations. What we'll do next is something that we haven't done in a while, which is inequalities. We're going to see what inequalities look like when they are quadratic.